So welcome in second part of viscosity measurement. We've seen the part of the machine which is called viscometer and how to deal with different fluids such as, for example, honey and ketchup, water and yogurt. And we shall see the use of the equipment after we have defined these terms. Here we are going to define what is a viscosity and its formula and its units that it uses. First of all, the definition of viscosity is a resistance to flow. Simply three words that can define viscosity is that it is resistance to flow. Resistance to flow. Simple. Three words of definition of viscosity. Resistance to flow. So what does it mean? The more the liquid tends to resist the flow, the more it has viscosity. And we have also to consider the relationship of viscosity to temperature gradients. Viscosity relationship to temperature gradients. How does it relate? We shall see it later. So again, the formula for viscosity, which is this letter, small n like this, it is equal to shear stress over shear rate. What does it mean? Shear stress is that we are applying the force to break layers of the fluids. For example, if you have the fluids that has cross section like this, the upper section part of the fluid is highly strong because of the atmospheric pressure that is acting on the fluid. It creates the surface tension. This is the upper layer. Where the middle layers are somehow soft. They are somehow softer compared to the upper one. And the least one, the lowest part is the smoothest. It's very smooth, and it is the molecules are not in dense situation like this. The upper one requires much force to move, whereas the middle one requires less force, and the lowest part requires almost like no force at all, just a little motion to make it move, whereas this one requires extensive force to break these layers. So now the viscosity, that's why it is equal to shear stress over shear rate. So the more it goes faster, the less it is viscous. The harder it is these layers to move, the higher is the viscosity of that fluid. Okay? For example, the fluids that are highly viscous are, for example, honey, ketchup, and so on. Whereas the the middle parts, like the one that we can consider that has middle viscosity, can be like yogurt, and so on. For example, porridge, yogurt, and so on. And the least that has the lowest viscosity is, of course, water. The one we used also to consider as the reference point. Come back to the units of viscosity, where viscosity is measured in Pascal second. This is Pascal times second. Because of what? We have also shear rate, which is expressed in time. And we have also to remember that the pressure equals to force over area. This is force and this is pressure. So that's why you are involving something like Pascal. It involves pressure. And another unit of viscometer or viscosity in general, it is centipoise. The equipment that we are using is using this unit, which is centipoise. So there is a relationship between centipoise and Pascal second. For example, if you want to convert Pascal second into centipoise, there is one factor that you have to multiply for each measurement of that is expressed in Pascal second to put it into centipoise. Then of course, come back here, this is tau over gamma, to put it in abbreviation of this formula, shear stress over shear length. Then the relationship between viscosity relationship to temperature gradients is that whenever we have the temperature, once the temperature increases, viscosity does what? Viscosity reduces. This is the first relationship. The second relationship, when the temperature drops, viscosity automatically increases. Okay? So that is the relationship that we can mention. So it is vice versa. Once one increases, the other one reduces or decreases. Once the other one decreases, for example, temperature gradients, once it decreases, the viscosity tends to go higher or to increase. Okay? That's now for this viscosity measurement. Let's come back on the equipment adjustment.